Hello, my name is Shabong from the Department of Physics from Asana Moscow University, and I will be talking about the different types of magnetic materials. The types of magnetic materials were divided into three groups based on their magnetic properties. This was done by Michael Faraday. Now, Michael Faraday was an English scientist who contributed largely to the study of electromagnetism and electrochemistry. The different types are diamagnetic material, paramagnetic material, and ferromagnetic material. And now we will be talking about diamagnetic materials. These are the substances which when placed in a magnetic field will get weakly magnetized in a direction opposite to the applied field. The magnetic properties of an atom are due to the electric currents associated with orbital and spin motion of an electron within an atom. Here the individual atom has no permanent magnetic moment. This is due to the fact that each atom in diamagnetic materials has an even number of valence electrons and there are no magnetic moments in the atomic level. This is because the spins of the electrons are arranged opposite to each other, thereby cancelling each other out. Now that was in the absence of the magnetic field, but however, in place of an external applied magnetic field, the induced magnetic moments of ions, molecules, atoms are directed opposite to the applied magnetic field. This results in a weak repulsive force on substance. This is because the applied magnetic field deforms or changes the electron orbital motion, leading to negative magnetic susceptibility. And now the properties of the diamagnetic material. It is feebly repelled by a strong magnet. Its magnetic susceptibility is negative with a very small value, and its relative permeability is slightly less than 1. And we know that the relation between the magnetic susceptibility and relative permeability is given by μr equals to 1 plus chi m. And the field lines generally like to pass through the surrounding air rather than material. And now we can see that the magnetic field lines generally prefer to pass through the air rather than substance. This is because the magnetic permeability of the diamagnetic substance is much lesser compared to air, so it does not allow the lines to pass through it, and the diamagnetic substances expel the field lines. And in the next figure, we can see that in the absence of a field, there is no net magnetic moment. However, in the presence of a field, there is a net magnetic moment. However, it is very small and is directed oppositely to the applied magnetic field. And now we will be talking about paramagnetic materials. These are the substances which when placed in a magnetic field will get weakly magnetized in the direction of the applied field. Causes. Here the atom or molecule has a small net magnetic moment. This is due to the fact of the incomplete cancellation of the electron spin and orbital motion, which if you remember was not the case in diamagnetic materials where the electron spin were evenly paired and therefore they cancel each other out. However, in the absence of an external applied field, the dipoles are randomly oriented in such a way that even they too cancel each other out, and therefore they have no net macroscopic magnetization. However, on the application of a field, the dipoles are partially aligned along the direction of the field. Its properties. It is feebly attracted by a strong magnet. Its magnetic susceptibility has a small positive value, and the relative permeability is slightly more than 1. The magnetic field lines prefer to pass through the material, which will be shown in the next slide. And now, since the magnetic permeability is more than 1, that is, it's more than that of air, it will allow the field lines to pass through it. And in the next figure, it is shown that the dipole moments are randomly oriented in the absence of a field. However, in the presence of a magnetic field, they will be aligned in the same direction, and hence they will produce a small magnetic field of its own. And now we will be talking about ferromagnetic materials. This is similar to paramagnetic materials in the sense that they both get magnetized in the direction of the field. However, the degree of magnetization here is very large in comparison to paramagnetic materials. causes. Here the atoms are grouped magnetically into certain regions called domains. The region of space over which moments are aligned is called a domain. In the absence of a field, the domains are randomly oriented, just as in the case of a paramagnetic substance, where the moments are oriented in a random manner. Therefore, it does not exhibit magnetism in its normal state. However, when it is placed in a magnetic field, even a small magnetic field or a weak one, the net magnetic moment develops and is very large. Properties of a ferromagnetic material. It is strongly attracted by a magnet. Its magnetic susceptibility is very high, and therefore its relative permeability is also very high. And then the magnetic field lines tend to crowd through the material. As discussed before, since the magnetic permeability is very high, therefore the magnetic field lines will generally crowd through the substance. And in the figure below, we can see that each compartment is the domain. And note that the single arrow does not mean that there is only one magnetic moment present in the domain. There are multiple moments in a domain, and the arrow just shows the direction of alignment. And since the direction of each domain are oriented in a random manner, therefore there will be no net magnetic moment. However, in the presence of a magnetic field, they will all get aligned in the same direction. And therefore, this concludes my presentation. Thank you.